Hello everyone. So in this video, I'm going to discuss about forward and inverse kinematics. So these are two topics, very fundamental concepts used in robotic arms. So before we understand these concepts, let's first answer a simple question. What is kinematics? Kinematics is the study of motion without considering the force that caused the motion. In robotics, kinematics focus on how the robot moves from one position to another. A robotic arm moves by rotating its joints, just like our human arm moves using shoulder, elbow, and wrist. To control these movements accurately, every robot must solve two simple important questions. One, first one is if the joint angles are known, where will be the robot hand reach? Second question is if the target position is known, what joint angles are required? These two questions are answered by forward and inverse kinematics. So let us understand them with neat diagrams. First one, forward and forward kinematics. So we have discussed about what is kinematics, why do we need in robotics, and every robot must answer these two questions. The first one, if the joint angles are known, where will be the robot's hand? And if the target position is known, what joint angles are required? So, first question, the question number one is solved by forward kinematics, and question two is solved by inverse kinematics. First, we can discuss about forward kinematics. So, before learning forward kinematics, let's understand what are the different parts of robotic arm. So, as shown in the figure, the first one is link. That is, arm consists of three links called L1, L2, L3. These links are connected by three rotating joints. The rotation of each joint is represented by Q1, theta 1, theta 2, and theta 3. The end of the robotic arm is called end effector or gripper, which performs tasks such as picking, placing, or holding objects. So, whenever these joints rotate, the position of end effector or gripper also changes. So, this movement is basis of robot kinematics. So, now let us understand what is forward kinematics. In forward kinematics, the joint angles are already known. For example, theta 1 equal to 30 degree, theta 2 45, theta 3 20 degree. So using these joint angles and length of the links, the robot calculates where its hand or end effector will be. The final output is the position in x, y, z direction or coordinates along with orientation of the gripper. Simply remember this flow. So known joint angles. If suppose we know the joint angles, then this forward kinematics it calculates end effector position, that is x, y, z orientation. When compared to inverse kinematics, forward kinematics is relatively simple because the input values are already available. Next one. Next, we can discuss about inverse kinematics. Suppose we want the robot to pick up an object placed at a specific location. This time we know where the object is, but we don't know how much each joint should rotate. For example, the target position is in x coordinate is 300 mm and y is 200 mm. The orientation is 45 degree. Now the robot calculates the required joint angles, such as theta 1, theta 2, and theta 3. So this process is called inverse kinematics. So it is a reverse opposite to the forward kinematics. Here the flow is desired position. If we know the desired position, it calculates joint angles theta 1, theta 2, and theta 3. Next, we can discuss about the comparison between forward and inverse kinematics. The forward kinematics starts with known input angles theta 1, theta 2, and theta 3, and it calculates the end effector position. But in case of inverse kinematics, it starts with desired end effector position. It calculates required joint angles. Simply, we can say that for forward kinematics, the flow is joint angles to position. In case of inverse kinematics, position to joint angles. So that is the easiest way to differentiate these two. Next, we can discuss about what are the applications of these kinematics used in robotics. Different applications, if you see, these concepts are used in almost every robotic arm. First one is pick and place robots, welding robots, surgical robots, humanoid robots, and industrial robotic arms. So without forward and inverse kinematics, a robot cannot move accurately or perform automated tasks. So let us summarize. In forward kinematics, it calculates the position of the robot's hand from the joint angles. But in case of inverse kinematics, it calculates the joint angles needed to reach desired position. These two concepts form the foundation of robot motion and are essential for designing and controlling modern robotic systems.